Welcome everybody to another debate review. We've been doing quite a few lately, um, but tonight we were going to do a different episode, but other people weren't able to make it for various reasons, so I decided to change it up and just do a debate review. Um, and I think it'll be fun. The presentation from the True Earth side is awesome, and of course the Globe side is basically like, look at the science books, we figured it out. But yeah, let's go ahead and jump over to the main screen. And I guess my camera's not up. Let's pull that up. And so. I had a good Sabbath today. We had a get together at our local congregation. It's just right over the other side of the mountains from us, with Francisco and his wife Carla, as well as others, and that was awesome and blessed. And so got back from here and kind of settled on this debate, and I think it's an interesting debate. Let's just get straight into it. Let me pull this up big for everybody. What is it saying? Your camera is sending low frame rate. This may cause high system load. Why? Why is my camera doing that? Interesting. Shut this off for now. And let's just get it started. Oops, hit the wrong button. 1 second. Oh, almost did it again. Yeah, so I think he made a good point there. This is a debate that's been going on for centuries, yet they want to act like it has been case case closed, point proven. We've known for thousands of years that it's a globe. Yet we can see through historical means that this debate has been going on, like you said, for centuries. And of course, within 1969 and the supposed movement, moon emissions that supposedly squashed it all, right? Like we know, for per the moon landing, that of course it's the heliocentric model all along. How dumb the Bible for thinking anything different. Oh wait, so silly. Thank you, my love. You can't hear the video. Why? Thank you, my love. Okay, I'm gonna push this back. Apologize, everyone.
Hypothesis versus a null hypothesis. The reason for doing this is we can analyze evidence in a way that gives falsification so that we can have a mutually exclusive outcome. So the Earth is either flat or it's either a globe. Now, if we falsify our null hypothesis, then that gives evidence that the Earth is likely a globe. So, a quick refresher on how the null hypothesis works, you can turn to the US justice system, where innocence is presumed and that has to be falsified so that you can be convicted for guilt, right? So, innocent until proven guilty is the staple here. So, if you're going to provide something other than the null, you need to provide mutually exclusive evidence that can falsify that or show that that's likely false. Now, I can't tell you what the shape of the Earth is, but I can tell you what it likely isn't using this scientific method that's also approved for how drugs and whatnot are uh, administered, like when they do surveys and stuff on them. All right, so we also have how we're going to interpret the measurements that are going to be put forward to show mutual exclusivity. And this is all going to be done optically, right? So like theodolite measurements, looking at the stars, positions of stars, etc. So we need to understand the visual field and the spatial field, where it is asserted by the mainstream that both are Euclidean, when in fact there's a deviation from this spatial field. The spatial field is best represented by logarithmic geometry, in my opinion, because it's clearly not Euclidean. And what they put forward is that you can use curvature. You can use curvatures of different types. So hyperbolic. You can use negative curvature constants. You can use spherical curvature, all to describe different observations. But under different experiments, these different curvature theories fail to explain the physical location, the Euclidean three-dimensional location of an object under these experiments when they're done. So there is no unified optic theory that explains everything all at once unless you incorporate them all. That's why I say it's logarithmic, because along that scale, you could incorporate the hyperbolic, ecliptical, and spherical and linear geometry along that based off of relative distance to you. So this is an ongoing debate that's been going on since at least over a century now, since the mid 1800s. So in addition to that, astronomy is built up in how we perceive the stars in the realm around us is through a dome of vision. And this is true no matter what model you believe in. Here we have astronomy from a book from the 1920s, New and Old Astronomy, where they're talking about how we see in a dome. And this creates the illusion that we see the sky in a perceived dome, but that's just an illusion because the Earth is actually a sphere, so don't be tricked. But that's what they acknowledge and put forward, that we see a hemisphere of the sky projected into our dome of vision. And of course, this corresponds to ground positions, which will later be turned into a map. But still, it's important to understand how everything is apparent. We only see the apparent, never the physical. And this is also noted in a 1970s book on solar panels, where they note here, they say the sky dome is the visible hemisphere above the horizon in all directions, right? So what they're saying here is that relative to the time of year and relative to your latitude, you're going to perceive the sun arc across the sky as if it's in your dome of vision, and the elevation will correspond to your latitude and also the time of year. Now, NASA is explaining the same thing with the moon illusion, and where the moon appears bigger than they say it is for its physical size. And here's the diagram that they're giving about the true position of a celestial body versus the apparent that we see. And we never see the true, always the apparent, right? There's not two moons, there's not two suns. We only ever see the apparent. And here we have, so that's to understand that this is true on either model, no matter what you believe. Now, we have what we talked about earlier with the stars being mapped to ground positions here. So we have a coordinate system called the graticule. Well, this is represented by the latitude and longitude lines of this coordinate system, and this can be projected over different types. So we have cylindrical.
Thank you, my love, and welcome, Wild Man. Good to see you. Shalom.
Conical, globular, azimuthal, equidistant. You can, anything that does this, that uses the lat long, as long as you use the corresponding corrections or use the projection in the correct way, you will get the desired outcome that will get you to where you're going with respect to positions of the stars. So if this is true on a flat Earth, where your azimuthal grid follows you around as you move relative to your latitude, you perceive the sky projected into a local dome, no matter where the physical objects are, if they exist at all, is true. Same for the globe here. We're looking at the exact same thing. These are equivalent. Neither one falsifies the other. They're all using the same latitude longitude systems, which is just indicative of a position of celestial bodies at a specific time. It does not assert any dynamics. So what's the proper way to analyze this? Are we going to look through a theodolite and simply say the Earth measures flat, the Earth measures globe? Well, no, that would be insane, because we're not using an external reference, and the only external reference that we have is already asserted by the graticule, so we need to falsify that. So we're going to say that the Earth measures flat or it measures globular with respect to the stars, right? Now, we're going to use empirical observation of the motion of the sky and the known positions of the stars and the units of measurement of distance that are derived from that graticule coordinate system with respect to those positions of the stars to test and do a falsification of our hypothesis and null hypothesis.
So something that I think is interesting. So I'll be the first to say that I think it's kind of silly to use the stars to figure out what the Earth is. Now, what's interesting about what they do is they do it with the intent to show that per the so like he explained in the beginning, it's a null hypothesis. So it's innocent until proven guilty. And so he uses their own math, their own trigonometry to show that, okay, well, you're saying our long distance observations don't work because of refraction and etc. Well, okay, we'll use a different system that we can get rid of refraction, and we can make these calculations and see where they end up. So let's keep checking. or at least let's keep chugging.
It's just using the relative elevation angle based on how far away an observer is and the relative elevation between that observer and a physical obstruction, i.e., a mountain peak, for example. So we have an observer here and we have a distance and we have the elevation between them. We can use trigonometric functions to determine what that corresponding angle should be. Once we have that angle, we can go into stellarium. We can go on top of this mountain peak with that same exact angle. We could wait until a star matches up with that angle, and we could write down the time. We could wait down here on the ground at our observation point, and when we're looking in the sky, when that star intersects with that mountain peak at that specific time, if we can no longer see that star, that means that that star is physically obstructed by that mountain peak, right? We don't care about refraction or anything like that because if it's no longer visible, it's no longer being refracted. That's all that matters. And this gives mutually exclusive outcomes based on the trigonometric functions because one is planar, so one will show the elevation angle of this being higher based on just the trig function, and the other one, removing 8 inches per mile squared away from the distance, will leave you with about minus 200 feet. So when we plot this out, we get two mutually exclusive predictions and outcomes for the positions of the stars and that mountain peak for the timing in which it gets occluded. It'll take longer for the star to get lower in the horizon, so the globe predicts a longer time. Right, so what we have here is 39 measurements over seven different mountain peaks in different locations and different times that show times that only correspond to a flat Earth. And when you use this trigonometric function here, where the altitude of the peak is equal to the altitude of the observer plus the distance to the peak times the tangent of the true elevation angle, you can backwards derive what the actual physical elevation would have to be to correspond to that angle. And you can compare plus or minus to the globe measurements. And from that, you can take differentials from the two and see which is true or not on average. And we don't have a single measurement that corresponds to globularity here. Now, I ask you, if alpha is equal to alpha, then by those trigonometric functions, the Earth is measuring planar with respect to the stars. That is a geometric falsification of our ability to falsify our null hypothesis, right? So if the Earth were a globe and we had different timings, if alpha did not equal alpha, then our null hypothesis would be falsified and the Earth would likely be a globe. And I would be here debating two other people as a glober. I'd be the glober debating two flat earthers. And I'd be zipping them up with this. Because this is a mutually exclusive measurement. You won't find any mutually exclusive evidence in this debate, very likely. All right, so to argue against this, you would have to suggest that trigonometry is an unreliable witness, which is ironically how the globe is supposed to be proven. So is Pythagoras a liar? Well, claiming that the Earth is a globe without mutually exclusive evidence is using and affirming the consequent fallacy. That's why we're using the null and null hypothesis analysis to apply to our cosmological and physical reality. All right, that is the end.
Thank you very much. We'll kick it over to Shane. Thrilled to have you here as well. I'm going to take, let's see, unless you're going to show Shane's PowerPoints from your side, Alan, in which case you can just pull those up. Otherwise, I'm going to cut off your screen share.
Yep, no worries. Go ahead and cut it off.
You got it. So let's see. Shane, what I'm going to do is I'm going to decline only because otherwise it'll show both your and Alan's at the same time. Let me just first stop participant sharing, and then I am ready for you, Shane, for your PowerPoint. If you want to hit that share button one more time.
There we go. All right, good.
Yes, sir. Thank you.
That.
Perfect.
Right, so to go along with what Alan said, we argue from the null hypothesis position, right? Our position here is that Earth is planar and measurements of curvature are thus dependent on the position of celestial bodies. So we're going to offer some evidence that that is the case. Also, the alternative position would be the Earth is globular, right? And measurements of curvature are independent of celestial bodies. Not so, as we will see as we move forward, right? So some evidence we're going to put.
That is actually like such a high IQ, the statement that he just made there. Let me go back real quick.
Fourth real see as we move forward, of curvature are independent of celestial bodies.
The Earth is globular, and measurable curvature independent of celestial bodies. They get the curve by the celestial bodies, not by being able to actually show the curvature in the physical realm, right? It should be measurable, and the curvature should be measurable regardless of what's happening in the sky, and it's still flat. And what's insane is here shortly, the first thing you see McToon do is say, we went to Antarctica, we saw the 24-hour sun in the sky, boom, the Earth is a globe, which is exactly what he's arguing they're going to argue. It's high IQ for sure.
Not so, as we will see as we move forward, right? So some evidence we're going to put forth real quick is some laser measurements from FE Core done in 2018. Something you'll hear repeated often in these debates is that flat earthers never bring evidence, never bring measurements. As Alan just presented, we have celestial theodolite measurements and evidence, of which I believe, if you look at the summation, is about 39 different measurements from 7 different peaks. And over here, we're going to have different, I think 7 different measurements as well within 2 different places of extreme flatness, absence of curvature. Of course, if the Earth is a sphere radius 3959, it has to bend with an observed rate, 8 inches per mile squared. Laser tests falsify this observation in plenty. Here's a very well-known published document of all their data, the instruments they used, the results they got, the corrections they made, the variables that they controlled for, including refraction, temperature, atmospheric opacity. They did everything they possibly could. They had a custom built laser, this thing right here, they call it the Salad, and then they built it to make these precise measurements. And over again, on each 7th measurement, for all 7 measurements, continue to falsify the curvature rate. So this would be evidence to support the measurements of flatness as we move forward, right? All of these separate measurements have all the different calculations. They did the globe side, they accommodated for the spheroid model even. We went.
It's literally so insane. If the Earth curves, we're done, right? If there's a curvature at any point, we're done. If it's curving at the rate that they say it should. Funny enough, there is no evidence. They can't show the curve. We can show over and over and over laser tests, long distance observations, mirror reflect tests, like over and over and over. But hey, look into the skies, guys. You can tell it curves. So it's literally so insane.
For the WGS84 corrections over here, and they corrected for humidity, temperature, literally every variable that you'd want to control. Here's all the instruments and technical data. I'll post both the link to this PDF and the video in the chat in a second. Here's the first measurement. Here's the second measurement. Every single time, absence of curvature. So
we are at 12 minutes. If you guys would like a couple more minutes, that's okay. But that's 12 minutes, or I started it at the start of Alan's presentation, just so you know where we're at.
I could do like 30-second wrap up. I'm
Sure.
good.
You bet.
Cool. So the other side of this would be the measurements of curvature, as in geodetic surveying, which has to have previous dimensions of the Earth known. You can refer to the American Arc of the Parallel, mctoon.net, at which you'll find copious amounts of corrections to longitude, latitude tables, and adherence to the spherical graticule, right? Corrections to latitude, longitude, as we see here. Of course, if they don't have these spheroid measurements, don't fit the curvature of the arc, they'll swap out the spheroid model on the fly. That's the point of having multiple models. So that would mean that we failed to falsify the original hypothesis that, of course, Earth is planar with respect to the star. With respect to the stars, because all measurements of curvature have to comport to the stars. So I'll end it there.
Thank you very much. And with that, I'm going to do is stop your share. And then I want to let you know, folks, if it's your first time here at Modern Day Debate, I'm your host, Dr. James Coons. We want to welcome you, no matter what. This is a fan.
Antarctica in
Before we play that, let's see who we're dealing with here. McToon is about to talk, so let's learn about the the McToon family.
The McToons are a legendary family trope of comics and jesters of times ancient. Many more than many tales have been told of their exploits across the globe. Throughout their generations, many of their kin have reached such heights to be honored among kings and rulers. And, believe it if you will, have even reached the heavens, exploring the vast emptinesses of both space and their minds, desiring their singularity with the universe itself. Join me as I tell a few of the many more than many tales there is to tell about the McToons. Once upon a time, long ago, there was a man named Micah. Micah often caused others to laugh with his odd and unsavory behavior, as he would tell wild tales. One day, while searching the wood for food to feed his empty stomach, he stumbled upon a cave and fell into its depth. When he reached the bottom, he met a sad dragon who thought of him as a palatable snack at best. And Micah, at the sight of the dragon, did the only thing that came to mind, and began to declaim to this ancient serpent a tale he told often.
Listen to me, I know the truth of the world. The earth is not flat, but it's totally curled. A ball is what we sit upon, and the sky reaches forever beyond. Things fall down because of the bending of space and time, not because of some great creator's design. Give me some food or gold and I'll tell you more. Like how the earth has a liquid metal core.
The dragon's deep-bellied laughter filled the halls of the caves, such that all the nearby towns could hear its rumble. Appreciating the ease to its anguish, the dragon gave the men a map that would bring the McToons a vast fortune. A long time ago, in a place far away, one such McToon was able to bring peace to a war-ridden republic. Unable to align themselves together, destruction of all seemed imminent. However, with vast wealth at his back, this McToon called a meeting to include all the leaders of the collect. And as he had practiced many times within a mirror, this time standing in front of all those summoned, and this is what rang out of those very halls.
Listen to me, I know how to get to the moon. Plus, with my brand new industry will boom. The team I constructed will perform perfectly. No difference between simulation and real will be seen. We will make so much money just with the merch, and that is only one of the many perks. Now give me your respect in gold, or all your dark secrets will be told.
Not many heard their nervous laughter, but many would pay nonetheless. During these modern times, another McToon, a legend unto himself, has been made known. During this time, he has made thousands upon thousands upon thousands upon thousands of people laugh. Here is such a performance.
A fake rap group that I was in. We were terrible.
You still got the hammer pants?
Joke. And I never had them. I had a size. I still do. A size 60 jeans that I bought at a hardware store to go golfing in, and I had to make. I used a metal hoop to make them stick out. Yeah. And I used I made straps over my shoulders out of phone cord. I think it's well translated today as either expanse or sky. When it comes to the shape of the earth, it doesn't matter. We can just go look at what the shape of the earth is and then determine that independently. And then we can see whether or not somebody's interpretation of the Bible matches reality. If there was a holy book that very specifically said something that contradicted reality, that holy book is wrong. I think that's definitely a stretch. You can't find a group of 3 people that are unanimous on definitions. But I would say that the people that had that opinion were wrong. It's empirically falsified, right? You can go test it yourself. So they're simply incorrect. But Hasidic Jews disagree with you on that. I believe that this is somebody just writing what they wrote, and that if you think that this is literally saying that the earth is flat, then you are literally claiming that the Bible is wrong. I don't care. I don't use this as evidence that the Bible says anything about the earth. All we need to do to figure out the shape of the earth is not look at the Bible. We just go look at the earth. Well, it may be that people heard. It may be something that was added to the story. Yes, my answer is don't understand how glare works.
Okay, so glare.
You keep putting the same thing on me as if your interpretation is the only valid one, Sean. It's not. Be honest with me. Come to it in good faith and acknowledge that I don't need to. I can just measure the shape of the earth.
That's the laziest thing I've ever heard, Michael.
I can go measure the shape of the earth. I've done it. Do it right now. 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 Yeah, I'm well versed in the math. Sean, you can't do the math. I know you suck at math.
Michael, I'm asking you as a Christian, how much of the Bible do you believe? You only believe the parts. Matter. Which parts about it do you believe? I disagree with the parts about that you think say that the earth is flat. And I'm concerned about people thinking that the Bible is wrong, and you are saying that the Bible is wrong. Sean. Michael, what's the definition of the radius value?
Your interpretation of
what's
the Bible
definition of the radius value?
Reality.
What's the definition of the globular radius value of the earth?
What's the definition of it? Mm-hmm. It's the distance from the center to the perimeter.
I don't agree with your definition. I don't agree with your interpretation of that. You see how stupid that is? Yeah.
It is, because that's a science topic. Because the earth is factually a sphere. 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 And you are claiming the Bible says otherwise. Fine, let's accept your definition.
I had so hoped that we could do better tonight.
Your definitions. Yeah, but Sean. Yeah, but Sean. Yeah, but Sean. Yeah, but Sean, the earth is factually a sphere. It's been measured. And your math sucks. Why are you interrupting me with a lie, Sean? I'm going to make you a liar, Sean. 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 Sean, listen up. I have it. Sean, listen up. I have it. Definitely disappointing, Sean. You've been destroyed. Your flat earth lie has been exposed and laid bare to everybody. To everybody. To everybody. To everybody.
What a literal joke. Okay, let's hear what this comedian has to say.
December, and that was quite a trip. Thank you to everybody that helped pay for it. So I'm going to also present some hypotheses. Now, this hypothesis and null hypothesis stuff is a rather rigid way. It's not necessary to do experiments. You can just simply falsify things, and it doesn't absolutely always require a null hypothesis. It doesn't necessarily follow that you can always even put together a null hypothesis. So anyway, we've got 4. Experiment number 1 that we did there was whether or not the sun circles 24 hours a day. The globe predicts that it will, and flat earth has true predictions. They weren't very consistent about that. Flat earthers generally said that the sun would set, but if you actually apply the geometry, that the sun would actually be due north at local solar noon, and then move sideways, and then at local solar midnight, it would also be due north.
The sun do something in the sky. That means that the earth is the ball.
And so when so either of those two predictions we will be testing, we did test. And what did we see? Well, in fact, this is what we saw. We saw the sun do circles 24 hours a day. There is no prediction for flat Earth that we would see the sun due south. I'll pause it when it's due south. I gotta play it again. I'll show you it. Right there, play again. So right over there, that is due south. In fact, you can see on the bottom of the screen there, I've got some snow boulders that I put together. We used the globe model to predict the angle of the shadows and of the sundial and the length of the sundial based on previously computed based on the radius of the globe and the position of the sun in relation to the globe, and they completely matched. It was absolutely another confirmation of the globe. But this is simply about whether or not the sun is seen due south, and this was seen due south. So if the Earth is a disk, as both Alan and Shane presented in their presentation, then the sun would have to be 180 degrees opposite, absolute opposite direction. The margin of error of this is all of it, all of the error. All right. So globe prediction confirmed and flat Earth prediction falsified. Experiment number 6, we saw star trails when we were there. So the flat Earth predicts something very specific, and the globe predicts something specific. The globe predicts that there will be a single center of rotation seen due south, and the flat Earth prediction is that there will be horizontally moving stars when you look due south. And this is the globe prediction, a 3-dimensional prediction of the globe here in just some software showing what it's supposed to look like. And here is I have behind me, I have that dome here. So the dome model that both Shane and Alan presented. There it is. I put stars on it, and I used a black light. That's what the color is. And there you go. You can see these stars are moving horizontally. That's the flat Earth prediction. Horizontally moving stars when looking due south, especially from the south where we were in Punta Arenas. So there's our 2 predictions. What did we see? In fact, this was the video that I took. It's a series of stills that are stacked in the P1000. We saw the star trails going around a center of rotation clockwise in the sky. So it matches the globe prediction when we look south. This is a video that Will Duffy took. Again, there is stars moving around a center of rotation there that we see due south. All right. And so let's look at the declination for A Crux and Beta Hydri. They are in the globe celestial sphere, right there, near the center there, the south celestial pole, and then the flat amazing. Both all right.
All right, you guys got that? Got a lot of stuff here. Evident. We're gonna symmetric. Okay, so we would expect on a globe things that happen in the northern hemisphere mirror those that happen in the southern hemisphere. This is just geometry. Okay, so you can see how the Tropic Capricorn is much longer here in the flat Earth than it is on the globe. Obviously, that they predicted to be the same length, right? So how do we test something like this? Well, some simple observations that are mutually exclusive are direct flights. American Airlines 52 at 27 degrees north latitude matches that of Qantas 64 flight at 26 degrees south latitude, almost the same exact latitudes. They both fly 7,000 miles about. They both fly the same speeds. They both fly there at about 11 and a half hours. So that alone is just a mutual exclusive thing for the globe. I mean, it's symmetric, right? This flight on flat Earth would look something crazy like this. Direct flight, right? Even if you fly straight across and don't fly around this arc, which you do according to the flight data, it doesn't make any sense. These are the same times and distances, right? But it makes perfect sense on the globe because the globe's symmetric.
Isn't it always interesting how they always use the Gleason's projection? It's like, this is the best idea, but we aren't saying that this is where Australia is and this is where North America is in this comparison. We have no idea how the distance actually pan out. Like, we've never had a person that was paid to map out the Earth from our perspective. So for them claiming we don't have a model, yeah, of course we don't have a model. How do we make a model in this way? It's like they're literally asking for an impossible request, and then all they do is say, "Oh, look, we have this data that's presented, that's from our perspective, that's had millions and billions of dollars planted into it for a reason." So, anyways, let's keep going.
Okay. This is what we expect. Another example of the same thing. This is China Airlines 6, Qantas Flight 27, 34 degrees north and south latitude. Again, direct flights that completely disprove flat Earth.
I'm going to skip a little ahead and just get
what we see is it going to the left.
Some interesting stuff.
Distance.
Which is tagging me in.
Something of noteworthiness, you need a null hypothesis.
No,
so
you don't.
If you're okay, well then good luck. How would you get your PhD then? You know that they do that through a null hypothesis, right?
Oh, James, do you have a PhD? Did you have to have a null hypothesis?
Instead of dragging me into the debate, I do want to just redirect us. So, gentlemen, are there any points from the openings that you would like to discuss that you've been burning, just with a burning desire deep in your loins, that have not been covered yet?
Let's address the laser measurements from FE Core in 2018. The only way that would be not mutually exclusive, right, is if you argue refraction at any distance. Now, that was a measurement over 7.5 miles, but there isn't an actual distance that you could tell me that where we can make an observation past that where you wouldn't claim refraction if it's made. So that also would be an...
That's literally what they do. They just keep moving the goalposts. They're like, you can't see past 5 miles. Here, look, we saw 7 miles. Yeah, of course you could see 7 miles because of refraction. But no matter what you do, you could never see past 10 miles. Look, here, we looked at 12 miles. That's impossible. Obviously, it's due to refraction and atmospheric. It's like, well, you said we couldn't see past. It's like, that's all they do is move the goalpost more and more and more. And so when we have actual evidence that disproves their claims, they just skip over it. And I bet you McToon and McGlobe will do the same thing here. They won't talk about the distance.
Unfalsifiable position, unless you can give me a distance at which we can make an observation in which you will discount refraction.
James, you mind if I share screen? All right. Here is from the FE Core document there. You see this is measurement number 5. They measured the temperature at water level and at 2 meters above the surface of the water. You can see here 11.4 degrees Celsius at water level and 13.3 degrees Celsius at 2 meters above the water level. That's almost 2 degrees Celsius difference. Now, this is called the lapse rate, is the amount of temperature change in a vertical linear distance. The 1 degree Celsius per 10 meters, then that causes the arc of the curve of light to have a radius of about 6,370 kilometers.
The radius of Earth, oh man.
And this was an even steeper gradient, a significantly steeper gradient. So this is documentation showing that the radius of the arc of light is going to be significantly less than the radius of the surface of the Earth that's been measured. So now when they did it, they didn't actually compute the effects of refraction correctly. They did it horizontally instead of vertically. I don't know why. It was pretty embarrassing for them. But anyway, this is right here confirmation of the globe right here, because this is showing how incredibly strong they needed the refraction to be in order to see it at that distance.
So for those that didn't catch it, he glossed over it. He said, "See, the temperature of the water is lower than it is 2 meters above it. This reflection causes the laser beam to bend around at the Earth." Well, what rate does it bend? Well, just consequently, it bends at the almost the exact rate of the Earth. So what is a laser doing? It is literally bending its light, because lasers and all the, every time we play with them, we see it bend and bend and bend. It's like that's what they literally say. No, there is no measurement. Not now. The goalpost is literally there is no distance that you could see where your vision would be obstructed because the light would bend around because of refraction, the humidity and the temperature. The light will bend around the curve. It's literally so dumb.
So when can refraction cannot account for curvature, right? So we're looking for falsifiability. At what distance would we make an observation that you wouldn't induce refraction?
Why didn't they
refraction wouldn't
account
be
for
an option?
refraction? Why didn't they account for it properly?
Of course they did. You just argue that they don't because it's unfalsifiable.
They didn't do it right.
We started, right?
Bring up where they did the refraction. Go ahead. Show us in the document.
The point of bringing up the laser measurements,
let's
right,
see it.
is to
Let's
say
see
that
where
it's
they did that.
unfalsifiable for you, right? Because
Please show us where they included that in their observation.
Is there a reason why you won't bring it up?
Which is why we bring it to the celestial theodolite, which is mutually
No, you brought up FE core. You're running from the FE core measurement now. Thank you very much for running from your own first law of Flerf confirmation.
No, showing you that the unfalsifiable position of refraction, and no matter what the distance, as you
James, I'll share. James, I can share
it, right? That's why the celestial theodolite is mutually exclusive.
Yeah, because James, I'll share what
only
he's
presented in a dichotomy, as we reduced it to, then you can't eke out of it with these ridiculous refraction claims.
All right, James, do you see my share here?
Yes.
Okay, so here is the just a couple pages later. Here they are using a this is their attempt to compute the amount of refraction, and what they did is they took the temperature at one side and they took the temperature at the other side. They did not take the vertical temperature gradient, and then they treated it as two distinct mediums, only two mediums instead of a continuous medium, which would be wrong even if you're going to do it horizontally, which is the wrong way. And then they just use the modified Edlin equation, the fine equation, but they applied it incorrectly. You need to do it vertically. They did it.
Okay, so he wasn't, hey, give me a critique of what we did. Okay, even if they're wrong about this, he didn't say, what he said is give me a distance in which we can go to where fraction won't be accounted. And he literally can't. Because they have to say that it would always be going down with the curvature of the Earth. Curvature of the Earth.
Right here, this is embarrassing. Horribly embarrassing, low quality understanding of what's going on and how to compute refraction. Go to Andrew Thomas Young's website at San Diego State University. He goes over all of the ways that you can do this. He has citations. He is the one that has citations of the 1 degree Celsius per 10 meters vertical lapse rate will give you a radius of the Earth,
Also, the reason why he wants you to get the vertical is because he's saying the laser will be going up into that vertical air, right? Which is above 2 feet above, which it would have to do if it was curving. But if you're doing side to side and you're not saying it's curving, you would do it exactly how they did it. No different than the way that they set up their dumb equations, with it suggesting as it already is.
Arc matching the radius of the Earth. And again, when doing it correctly, you will find that the lapse rate is significantly stronger than that, giving a radius of the arc of much shorter than the radius of the globe.
It
Infinite
almost looks
refraction.
like
Got it.
it almost looks like they assumed the Earth was flat when they did that calculation.
Yeah, I already said that. Of course they did. Just like y'all are in every single equation, the radius value is baked in. And so when our numbers don't match your R value, you say we did it wrong because we didn't assume your math. It's so dumb.
Everybody on the same page? Why did you get so quiet?
Oh no, sorry, I was just waiting. Okay, so well, it's important to note, like even if the refraction had been done correctly, right? There's different types of refraction that could be applied different coefficients. What Shane pointed out earlier in the arc of the parallel that gives agreement to the coordinate system is riddled with different refraction coefficients that are applied in different lateral refraction assumptions that are made. So when you get
Let's see 'em.
into,
I don't want to I don't interrupt, but this is your
okay,
test, right?
yeah, just 1 second.
Okay.
As I'm continuing, right?
I don't want to interrupt. Let me interrupt.
Shane will pull him up in the background saying, like, let's see him. They're there. He's got him. So I'm going to continue on now. But anyway, this is why it's important to have something that can differentiate between these measurements, right? Because you're asserting that there's a refraction that was erroneously calculated. We're asserting that the measurement was good, and that there could be. Let's give refraction the benefit of the doubt there. What can we do to satisfy the conditions of our null hypothesis that are independent of refraction? That's why we turn to the celestial theodolite when an object is actually blocked. Because when you introduce evidence that isn't falsifiable, right? Which we talked about earlier, how there's not if it's not falsifiable, if there's no limit that's too far before you can, on that equation for refraction, then there's no limit, right? So we can't falsify it in that way. So we're going to introduce. So that's why we introduced the celestial theodolite. So whenever you guys want to get to that.
So basically, to sum that up, what they're saying is y'all just keep moving the goalpost over and over. It doesn't matter what type of long distance observation we do, showing that there is no curvature rate. What we're going to do is we're going to use a physical object to obstruct it, to show you that per your math, it should be obstructed at point A, and per just the math as is, we're gonna see it at B. Let's see what goes from there.
But we're done with the lasers. Just want to be clear.
Okay. Sure. No, we could.
What equipment was used for that observation?
I don't want to talk about the lasers.
For the observation of what? The celestial theodolite?
Yeah.
Ooh, I have to look.
Do we know?
I'd have to look. Yeah, the specs are available. I don't know off the top of my head. It's a star. What do they call it? A star seeker or something like that?
No, that's a telescope. What was the angle measuring device?
Yeah, theodolite used.
Oh, you're talking. Okay, you're not familiar with the celestial theodolite, real quick, because you're thinking like an actual.
I asked you what equipment you used for your observation. Your theodolite.
I got you.
David
I got
White
you.
8300, I think.
No, that's for the measurement with not doing the celestial theodolite.
Yes, it is.
No, that's a measurement with a theodolite.
It's on your own video from.
Buddy. The measurement is done for comparison, right? Listen,
I mean, you don't have to call me buddy. I mean.
Oh, sorry. You're right.
This is your video right here, right, Shane?
Yes.
Okay. This is the David White 8300 that they used to take the measurement over the mountain.
Can you stop interrupting, please? That is a David White 8300. That is not the celestial theodolite that we're talking about.
It's conceptual, right? So
but he talks about using that and how to measure on the vernier scale on the theodolite.
This isn't used for the celestial theodolite, though. Do you understand that?
Okay. Go ahead and explain it. Go ahead.
How did he get the elevation of the mountain?
How did he get the elevation of the angle? Trigonometry. So he took the difference in elevation between him and the mountain peak and the elevation of the mountain peak. And then you can do trig to get the elevation for that. The tangent of that is the
very
angle.
confused because this whole article, this whole video, and all your videos since then talk about measuring the angle to the mountain peak using the theodolite, and then measuring the star angle with the theodolite.
That's ridiculous. One second. No, that is explicitly not what they say at all. That is a complete straw man of all those videos. That is not what they're about. They're about using a mountain peak and star occlusion timings to tell the difference on the relative angle. The beginning measurement showing that David White 8300 is for a comparison for optical measurements because the premise, right, the optical field and the spatial field are different. So we bought an old device, took a measurement optically, right, for the comparison, just the raw measurement to see what it would be, and then he used the celestial theodolite for the comparison. So what you're asserting is not relevant to anything. Now, I'll tell you this though, I'm not hiding from this. This is the point. You know what? It is relevant because this is the exact point of it. Because when you point that device to that mountain, guess what angle it measures? Guess. Go ahead.
I don't know. 2 degrees, 31 minutes.
About 2 degrees and
3 minutes.
So that one in particular measured the right angle, but then he got a better device. He got a Sokia something or whatever, measured 2 degrees and 19 arc minutes, right? Which corresponds to the globe prediction. Very cool, right?
Sure.
But our premise, remember, is that there's optical compression. We don't know if the Earth is curved or if this is an optical effect, right? So what we do with the celestial theodolite, now that we have our theodolite measurement for comparison, we've done our optical on the ground with the theodolite, we've got what the globe predicts, right? Now we calculate what the relative angle would be to that mountain with plane trigonometry, and we get the actual raw angle, and we go to Stellarium. Can I screen share real quick so I can show this, the diagram? Oh, he's AFK. What the ruck? Okay, thank you, sir. All right. Share. 1 second. It'll be nice to have the diagram for you guys. Okay. All right. So once we have our relative angle, the calculated angle, right? Differing from the iron. Okay.
Because what it's saying for me in terms of if I double click it, show me to a
spherical. It can only be spherical. I said we use spherical coordinates. Okay.
All right. Sorry about that.
My bad.
Now in
10 years, Melvin.
Oh, I'm so far behind. James is ahead of me on this.
Okay. Go ahead. Ready.
All right. So once we have our calculated angle relative to our distance,
right, we can go. How? I'm sorry. I don't mean to interrupt. I need to understand what you're doing.
Got you. So we have our observer here on the ground, right? Mm-hmm. We have our distance away from a mountain, right? And we could reference. Let's see. What I reference is this website right here. I'll get
is that a flat Earth distance or is that a?
No. It's using your boy Haversine. It's Haversine down.
So you're using Haversine. Okay, go ahead.
The Haversine is a trigonometric is a spherical trigonometric function.
Kind of a first law thing here. Okay.
Yeah.
Okay, please don't interrupt. But the Haversine, right, is a spherical trigonometric function that's used on a graticule, which is a spherical coordinate system to compute distances between latitude or longitudes. So it's fine, dude. That's part. And it's hold on 1 second. And it's also using units of measurement that are derived from the coordinate system. So of course it comports and works accordingly. Now the purpose of this is to test independently the geometry of the ground and the sky using both of them together instead of just using empirical observation, because the graticule, I don't know if you know this, but was derived from astrogeodetic surveying, which means that they took single zenith measurement observations of stars, and when they didn't get the angle that they thought was going to be where it would line up with their telescope, then they just asserted that the difference was due to Earth curvature. So that observation can't tell you alone the shape of the Earth. So was there something you wanted to add on?
Yeah,
ask a question about?
I have a question. So you have there the angle there over at the vantage point of 2 degrees is at 31 minutes.
Mm-hmm.
Okay, and then you have the angle at the top of the peak there as 2 degrees and 31 minutes, right?
Mm-hmm.
Okay, now, but they're 50 some kilometers away. So where did the numbers come from for those 2 minutes, 31 2 degrees 31 minutes.
Exactly.
From the theodolite
So no.
that he told me he didn't use before.
The theodolite doesn't give an angle of 231. It gives an angle of 219. If you actually watch the presentation, as you asserted. Hold on one second.
Where did the 231
Hold on
come
one
from?
second. I'm in the middle of telling you. If you actually watch the presentation as you asserted, Globey, you would know that the measurement comported with the globe, right? With what the globe predicts at 219. This calculation comes from taking the distance, right, and the relative elevation between the mountain and the observer. There's a whole spreadsheet we can show to calculate this.
Well,
Right,
the words off your
just doing
presentation say that means the elevation of the visitor center should be 2 degrees and 31 feet above my level if the Earth is flat. Right? Is that what you're talking about?
Well, first of all, that was Mike Heffron's PDF that
That's
he
what I'm
wrote,
talking about.
right? And it should be.
Okay.
Right? We're talking about this part of the measurements now, right? Whatever you're talking about, just focus on this because this is super important here, right? So for the measurement for Pikes Peak, where they say, where we have this 31 arc minutes, right? This comes from the distance, right? Which comes from the trigonometric functions from your boy, the Haversine, right? Which comes from the graticule, which gives us the units of measurement to even do this with, right? Now, that gives us an angle though, regardless. So we have this angle now. So now that we have our angle, do you agree that we can use trigonometry that we can get the tangent of this by knowing the elevation angle or by knowing the elevation difference and the distance? If we have those, we can get an angle, right? Any disagreements with Pythagoras?
I'm still curious. I'm still curious on I need some clarification. At the vantage point 2, you have also 2 degrees 31 minutes. Where did that number come from?
Yes. So what that number comes from is the intersection timing of when the observer on the ground no longer sees that star. In order for those two times to match up, then this geometric relationship alpha has to equal alpha, which isn't on this slide. There's their thetas, but the relationship here has to be the same here. Otherwise, the star would occlude at a different time.
But you are indexing against level at vantage point 2 and not vantage point 1, so it will be on the globe, it'll be a different value.
No, we're specifically referencing if there's curvature between the distance between this mountain and this observer. Because if there is curvature, then this mountain peak will be physically lower than the raw calculated 231 angle. Because if you subtract 8 inches per mile squared, you get 214 for what the globe predicts. So 214 corresponds to a different time and when this star would disappear. So you see how this doesn't have the same geometric relationship here with respect to the locations there. That's if the Earth were a globe, this is what would happen. So because this doesn't happen and these line up, that's why I asked at the beginning if alpha equals alpha, then the Earth measures flat with respect to the stars.
Well, yeah. So did somebody go to vantage point 2 and measure the angle to the star?
Oh, somebody going to the vantage point measuring.
On the other slide. On the other slide.
No. Yeah, I'll show you. Yeah, doing that isn't necessary because all we need to know is if the star is at this angle in time at this location, right, which is what is predicted, right, and this is what is referenced. And if it's not visible anymore at that time, then the only way that could happen is if there's a geometric obstruction that's at that elevation to cause that blockage. So the relevance in if you were to be on this mountain peak, we don't predict that you would see the star where it is. We only care about where the star isn't. And to do that, you use that by using the relative angle calculation here and the timing difference, because we never told Stellarium where we were. This is the beauty of the measurement, because if when you plug everything in, it'll make two different predictions to try and correct for where it should be. But the timing difference here shows that the geometry is actually planar.
So you said, I just want to be clear.
All right, so just to kind of sum that up a little bit, is basically what he's saying like they keep wanting to focus over here. How do you know this angle? How do you know if you're going to be here? No, that's not the point. The point is if this is a curve, then this tip of the mountain should actually be down here. Thus, you would be able to see the star and it wouldn't be occluded. But if it is occluded because it is being blocked by the mountain or the object, thus this curvature rate doesn't exist, and that is why we don't see the star. So the way in which that they're doing this experiment makes a lot of sense, and it also makes a lot of sense how they are quick to attack this part of it, not understanding that this is the effect of this, but this is actually what shows that there is no physical curvature. So super duper interesting. Let's see, where is it? It's at about an hour. We're at about an hour. Kind of lonely, to be honest. I've been doing no one's here with me today, which I understand it was kind of a last minute thing, but I don't know. If you're interested, go check it out. I'll go ahead and post this in the chat if you're interested in watching the rest of the debate. I know I'm kind of cutting it off early, but like I said, it's just kind of me talking by myself and watching a video, and I enjoy that y'all are listening with me, and for those who will watch later, I do appreciate it. But we'll go ahead and just call it here. Let me grab that link, and then I'm going to send it in chat. Boom, if you want to see it. Boom, if you want to see it. Thanks again. We will be back next week, hopefully. We got some pretty cool stuff actually coming. We're going to be talking about a really cool book that we found. And we're not 100% how we're going to do it, whether we're going to do it in live streams or whether we're going to do it in actual videos produced by us. So we're not 100% on that, but we're super excited to share this stuff. The stuff that we've seen, the stuff that we've learned in this book is absolutely crazy, and we're excited to share it with you. But until then, I hope y'all have a great great week coming up, and I hope y'all had a great Shabbat. But until next time, remember that ABBA loved you first. Good night, everybody.
It's your glory, conceal the mystery. You give us the honor to search a matter out. You raise up a standard to beat back our enemy. You establish this realm, and like a scroll you spread it out.